let f be the function given by f of x equals cosine 2 of x plus natural log 3 of x. What is the least value of x at which graph of f changes concavity?
For me, I think the easiest way to find this one would be by finding the derivative. Once I find the derivative, our point of concavity is going to happen when the first derivative is changing directions. Okay? So instead of finding the third one and then going to the POI. So let's find the derivative on this one. If I have f prime of x, and that's going to give me, what's the cosine derivative?
Negative sign.
Negative sign. And do we notice that we have a chain rule in here? So we have, you keep the inside, multiply by the 2. That's a derivative of the inside. What was the rule for the natural log? 1 over that.
3x times.
And then derivative of that, which is? 3. If you want to knock out the 3, that's fine, okay? Because I know they do eliminate. But since it's a calculator portion, let's type this in.
Would this go for y1?
On y1 only. So we have, and I'm going to start with parentheses just to be safe, times 2. And then I have 1 over 3x times a 3. And yes, you may simplify as you go. Make sure your mode, since we're using our trig function, it's in radian mode. Everything in calculus is in radian mode. And when you are ready, let's manipulate the window. Because my window is not taking everything from negative 10 to 10, I think it's safe to say from 0, one more number of 2.44 is 3. And maybe I can leave this as negative 5 and 5. So again, my highest number is 2.44, so let's make x max the next whole number. My lowest number is 0.56, my next whole number is 0, okay? If you want to leave that as 10 and negative 10, that's fine. So I'm going to actually draw out this graph on the side. So would you guys agree our point of inflection is going to happen down here? Okay? So let's kind of sketch this real quick. The graph is doing something like this, and our point of inflection is going to happen when f prime is changing direction. Isn't that basically our minimum?
Yes.
Let's find the minimum. Second calc. The minimum is option number 3. You select anywhere from the left of the bottom, enter, and to the right, and enter. And it's going to say, are you sure? I want you to calculate between those two. And the answer is yes. Should give us our answer of 0.93. All right, now let's go to number 11. Colin, let's read number 11, please.
If the derivative of f is given by f prime of x is equal to e to the power of, is that u? That's x.
That one's x.
3x to the power of 2. At which of the following values of x is the f of a relative maximum value?
So let's rewrite this. It's kind of sketchy. F prime is e to the x minus 3x squared. So if we're looking for relative maximum, let's go back to our PVA card. So all eyes on the board. Would you agree that's a relative maximum right here? That happened when f prime was at 0. So if I were to graph this, it's calculator part, right? Let's graph it. So we have e to the x. There should be a button with the, there it is. Second natural log gives me e to the x minus 3x squared. And let's graph it to where it's going to satisfy our conditions right here. So on our window, my lowest number is negative 0.46. I think the smaller whole number should be negative 1. What should be my upper whole number? 4. Are we okay if I leave that as it is? Negative 5 to 5 maybe? I'm going to leave it. It's pretty even. Okay. So let's sketch that graph. The graph is going up and coming back down. And when it is changing from negative to positive, or positive to negative, let's kind of discuss what that means. There is a minimum in what direction?
It's negative to positive.
Whenever it's negative to positive. And there is a maximum when the derivative is positive to negative. And I am looking for maximum. So which one is that going to be, on the right or on the left?
The right.
On the right. So let's see what that 0 is. And for us to figure out what that 0 is, I know we can find, you know what, let's try trace. Everyone click on trace. And it looks like it's pretty close to 1. So the one that's pretty close to is either 0.91 or 0.95. 0.91. Okay, let's try 0.95. That one looks a little bit less underneath the x-axis. Okay, so what's a better answer? Okay, here's another method. Eyes on the board in case you're like, well, what if on the AP test the number is so close, they look pretty much the same. When you go to your y equals, set one of them equal to 0, and let it calculate or graph both. And when I go to my second calc to 5, hover over to where it's close to the intersection. That'll give you the exact value of 0.91. Okay? Only if your number's too close to it. If not, you can trace it. Okay?